Our first presenter is from the United States as well. We're honored to have her here for the first time at a conference in the Czech Republic. Her name is Deborah Dull. Maybe you haven't heard of her if you're on LinkedIn and you're interested in circular supply chains or sustainability and logistics. I bet you've come across her. She's the Vice President and Global Sustainability Supply Chain Leader at Genpact. She's the founder of the Circular Supply Chain Network, the author of the book Circular Supply Chain, 17 Common Questions. She's held various supply chain roles at the Bill and Melinda Gates Foundation, 0100, GE Digital, and Microsoft. And she's a sought-after author and speaker, having published various books, articles, white papers, and spoken at dozens of industry events, like here at Eastlog for the first time in the Czech Republic. So I'd like to invite her up on stage, Deborah Dull, for her presentation, Circular Logistics to Improve Operations and the Planet. So, Deborah, the floor is yours. The clicker is yours. Looking forward to the presentation.
Thank you very much.
Thank you.
The symbol of power at conferences is the clicker, I think.
Exactly.
Think back to the last time something in your home broke. Could be a toaster, your coffee kettle, maybe a little squishy bit on earbuds that always seem to break or fall apart. For me, it was my suitcase. I travel a lot, so having the zipper break on my suitcase is really annoying. Why is this annoying? Think about then something that has broken, and you really tried to fix it. Maybe a zipper on a pair of jeans, something that has broken in your home. And it was very difficult to fix, I think. In my case, repairing the zipper on my suitcase costs more than my suitcase cost in the first place. And I think this is something we've all experienced. This is a symptom of the economy that we're in today. If my clicker works, then I can give you my big reveal. There we go. Okay. Today's economy is built on the premise of what's called planned obsolescence. This may be a newer term. It's not one that we use in cocktail hours or at conferences very often, but it's based on the idea of what I've just described. The items around us last only so long so that we then need to go buy a new one. Repair is terribly difficult to do. It's often very expensive, and this drives us to buy more items. This helps us to drive this consumption-based economy that, frankly, has served us very, very well over these last 100 years. But to understand, then, how we can be responsible and make money at the same time, we need to go back and understand how is it that we've ended up in this economy based on items that break over and over again. Our story starts 100 years ago in 1924 on Christmas Eve. This is Geneva, famous fountain. Imagine it's 1924, Christmas Eve. There's last-minute preparations going on. And somewhere in one of these side streets is an illegal business meeting. At this meeting are business owners. They all own the same product. It's a newer product. And they can't sell enough. So they're all facing bankruptcy. So they get together and they try to figure out, how can we save our businesses? What is it that we can do? There must be something, this new innovative product, we can keep it on the market. The product is the humble light bulb. I see some heads nodding, so maybe some of you have heard this story. In that room were all the light bulb manufacturers that mattered, Philips, Osram, GE, and so forth. And what they discovered, they did the math, and they found out that their light bulbs last, on average, 2,500 hours per light bulb. This was right as lighting was starting to come into the consumers' homes. And they did the math to say, look, we actually need to increase sales in order for us to stay in business. So let's take the light bulb from 2,500 hours to 1,500 hours, and we'll sell about twice as many, we'll make more money, and we'll all stay in business. So they all agreed to reduce the quality of the products that they sell to us in order for us to buy more. And what's interesting about this moment in time is it's the first time we see the word planned obsolescence written down. And we see it written down because they made an agreement. It's a cartel. And they agreed to fine each other if anyone was going to break this 1,500-hour cap. Timing is everything, of course. This is right around the time that Henry Ford was coining the term mass production. He believed, very importantly, that those building the items in the factory should be able to afford what they were building. So he had a vision for the middle class, and that then grew this middle class as this time in history began, which was very interesting. Peak of the second industrial revolution, which was all about mass production and, of course, electrification. So we see those light bulbs on the ceiling there that started this whole economy. Today's economy, then, is called the linear economy because generally items move in a line. We take them usually from the planet in some way. We make them very, very efficiently, and then they're declared broken, like our earbuds, like our kettles, like our suitcases. And this is essentially how our economy has grown for the last 100 years on this consumption linear-based model. And it has served us very well. We're lasting, we're living longer than we ever have. We're healthier than we ever have. We have a middle class like we've never had before. But it begs the question, can we take forever? Will we ever run out of what's inside the planet for us to use to fuel our economies and to fuel our supply chains? This is the question that a sailor asked about 25 years ago. She holds the record for solo circumnavigation, so going around the world by herself. And around a Christmas Eve or so, off the coast of Australia, she was doing inventory on her boat and doing math to figure out, does she have enough to make it back home to England? And she discovered, yes, she has enough, but she had this aha moment to say, just as I have inventory in my boat fueling my trip, will the Earth run out of the items we use to fuel our economy? So she learned about this take, make, waste economy, which has led to what I call mass ownership, which is a good thing. Again, we've done a favor to the whole world as we've become healthier and we live longer. But there's a few issues with the linear economy. The first is that our items really aren't used. This study has been done in various parts of the world, and it ends up being 90 to 98% of the time our cars, our items aren't used. If you think about those items around your home, we often don't always use every pair of jeans, every blazer, every kettle, everything we have. So this is one issue. In a circular economy, which we'll talk about, of course, items in use are adding value. So we need to give our items, our materials, more than one chance to add value. We go through a lot of effort to pull it out of the ground and process it into an item, and then we reduce the amount of time it can be used. That's our first issue with today's linear economy, is items are not used. The second is that our items tend to escape our value chains. What's amazing to me about the idea of pollution is that if we take this red cup, there was a sourcing team that really negotiated hard for the cost of the plastic of that cup. It was planned, there were arguments and S&OP meetings, that was transported, it was sold, it made it to the last mile, just to end up all the way down here, all the way up here, in a way that has escaped our value chains. This is Bill McDonough of the Cradle to Cradle Institute. He has this concept, he applies it to carbon, but I apply it to materials. He's saying, look, generally carbon is not bad. We're made up of carbon. If you look around, everything that's not metal or glass is essentially carbon. But the problem is when it escapes, it becomes fugitive. It goes out into the world and causes problems. And that's the same thing that happens with materials. Through our value chains, they escape. We've all made a value stream map, and we see where the value leaks happen. So this is our second issue, is we're losing track of this valuable material that we work so hard to plan, source, transform, move into our global economies. Next, The costs of commodities seem higher these days. This is actually out of date. This only goes to 2013. It's the McKinsey Commodity Price Index. I can't get my hands on the last 10 years, but being in supply chain, we're all familiar with the rising cost of commodities, of course. Now, through the 1900s, we see this marvelous reduction in commodity prices thanks to our operational forefathers, lean management, technology, economies specializing, and we had this wonderful reduction that then as the middle class grew, demand rises, our commodity prices rise as well. The challenge here is that we are actually legitimately running out of the materials that we have on the planet that fuel our economy. So in this periodic table of elements, the darkest squares have less than 50 years of known mineable resources left in the planet. Now, I say known because we always discover new areas, but that's what we know that we have today. And 50 years is not that long from now. And if, like you, it's been a little while since you've seen a periodic table, I've translated a few of these darker squares, and all of these, of course, are critical for us to use electronics, which now fuel everything from our cars to our toasters to our watches and so forth. So this is our third issue, is that we're actually running out. So what are we going to do? We'll go through one more issue here with today's economy, and of course you're all well familiar with this. We are disrupted today. I'll give you one example I like to give. The punchline may be controversial here in a room full of logisticians, but I'm a supply chain practitioner, so bear with me. Here we have a little fruit cup, often for school lunches for kids. And we see it says, packed in Thailand, seaside of cup for pear origin. So we flip the cup over, and we see the pears were grown in Argentina, packed in Thailand, sold in America, which means these pears went 18,000 miles to end up in a school lunch. Here's what blows my mind. I'm from a small agricultural town in the upper left corner of the United States. We produce 60% of America's apples. We also grow a lot of pears. We also have packaging facilities in my small town. But somehow, through specialization over the years, this makes more sense in our economy for us to do. The challenge, of course, is that every time an item crosses a border, it's at risk. It can be disrupted. And not even really a border. Anytime something's in motion, we know if we've been trained in lean, that is a form of waste. But we do it because it has made sense for so long. We can do this with jeans. A pair of jeans goes 40,000 miles before we ever put it on. The average meal in America travels 1,500 miles before it's ever eaten. My latest fun fact I've learned is that a chip crosses 40 borders before it's put into its final product. So we end up with this idea of very fragile operations, and we're all well familiar with how fragile we are. All caused because of this economy based on consumption, this balance of product quality and cost. How much can we get someone to pay me for the lowest quality possible, so they need to buy more? Also very interesting, around the time of the light bulb story, early 20s, there was a Russian economist commissioned to do a study to debunk capitalism. So he went back through the years and looked at capitalism and to see, does it work, does it not work? And he found actually it does work, but it ebbs and it flows. And he found that it comes in innovation waves, and they look like this. On the upswings is when innovation booms. Lots of money fuels startups, new ideas, innovative thinking. And then we have a peak, and we have a fall in innovation. During that time, lean ideas, belt tightening, layoffs, leaning out our operations, this is what means success. On the upswings, of course, we get venture capitalists, heydays, and on the downswings, those are more for hedge funds. We can see our time of the light bulb, and importantly, with my very mathematically correct wave drawn here, we're currently standing just about at the top of one of these innovation waves. If history repeats for another time, we are currently at an upswing of waves, and innovation is being fueled, new ideas is being fueled, and now very likely we're going to start seeing continued tightening of budgets, as we've already started to see. So I know a question was raised at the beginning of today's session, how do we afford any of this? But the tough thing is our window for innovation is actually closing if we are going to scale these ideas. Now, of course, innovation happens on the downswings, but the scale happens on the upswings. So what can we do in opposition to a linear economy? Of course, this idea of a circular economy. How do we circulate what is already in our economies, giving them more than one chance to add value? This story begins with a similar start to the light bulb story, but in the 1970s. Very similar. Business owners got together. They all had the same problem. This time they had the problem of fresh, affordable water to use in their manufacturing processes. This is an industrial business park in Denmark. Lots of water here, but that's salt water. So they got together and they tried to figure out how they might actually be able to solve the problem, and they realized they could share the water. This is still in use today, and it looks something like this. It's called the Kalundborg symbiosis, and it's an example of what's called industrial symbiosis, an idea born in the 60s with the idea that a co-location of industrial processes can start to mimic what we see in nature. And so we see the water flows coming from the lake and being exchanged. Energy flows in red, that's usually heat runoff being used from one process to another. That type of an idea is now being used. Heat runoff from local server farms, for example, fueling the local pool. And in some cases, we have a material exchange as well. So if we take this idea of an industrial symbiosis and we stretch it regionally, we can start to imagine the idea of circulating materials. Materials broadly fall into two categories, renewable and technical. Renewable is something that would add value if we put it back into the planet, water and composting, so forth. Technical it doesn't really work that way. That's more of the metals and the glasses. Plastics today are on the technical side, but I think it'll shift in the coming years to renewable. It is called the circular economy, and circles can be small or big, and they look something like this. This is called the butterfly diagram from the Ellen MacArthur Foundation, which I'll talk a little bit more about. Let's focus on the blue side. The size of the circle makes a difference here. The larger the circle, the more time, effort, money, energy is needed to return a material to a value stream. So if we think about the perfect situation here, it's use and reuse. Utilization goes up. This clicker can be used by every single person today instead of each of us having our own clicker. It's a great example of use, reuse, and driving value. Now, many people confuse recycling with the circular economy, but in this case, as we see, it's the largest circle of this economy model, which means it takes the most money, the most time, the most effort, the most margin, and frankly, usually reduces the quality of the product or the material that we're recycling. Plastic today, for example, can only be recycled 1.8 times. So our goal is to have as small as circles as possible and to follow the three principles of the circular economy in order. Many get confused or too focused and only think about the circulate part and think this is all about recycled inputs. But in reality, the first principle is to eliminate the idea of waste and to eliminate the waste that we know goes through our supply chains. Again, thinking about lean management, inventory, overproduction, motion, transportation, we know all of these are part of waste. Once we do that, we want to circulate the materials and then regenerate the areas around us. And just this morning, we heard an idea that will be discussed later today on how do we treat the communities around our operations with respect? How do we leave the areas around our operations better than we found them? One more concept of the circular economy that's not talked about enough, but really, really important is the idea of decoupling growth from material use. If we remember this chart that says commodity prices are going up, the anecdote is to decouple revenue growth from virgin material needs, virgin as in first-time use coming out of the planet. And if we can do this decoupling, that means our businesses can grow, our supply chains can grow, our economies can grow, but we reduce our reliance on natural resources coming out of the planet. And of course, we know this is possible. This is how we think. We spend our days thinking about variable costs and how do we reduce those while continuing to grow the business. And I bet you all have an annual reduction target that you have to meet every year. And if we think about our sailor, her name is Ellen MacArthur, and she has established a foundation. It's called the Ellen MacArthur Foundation, and is the main voice in this space. Great website, lots of free resources. If any of this is useful or interesting to you at all, you might go and Google the idea of a circular economy. So this section is so that you understand the difference between the topics that you'll see. I call it the Venn diagram of the circular economy. The most common search result by far that you'll see is around circular business models. This is really about the Uberization of the economy, how we can pay for transportation instead of buying a car. This will also get into the sharing economy, also gets into reusable packaging. Many of you may be engaging in a reusable pallet scheme, for example. Certainly the shipping container revolutionized our industry, but would fall into this idea of a sharing model. You might also see this idea of circular materials. This can come in a variety of ways. The perfect way to source in a circular economy is to actually start with a finished good, repair it, and return it to use. If we can't do that, we'll look for components, and harvesting components has been very, very popular with my customers recently because of the disruptions in the forward supply chain and the cost associated with some of the raw materials. They're finding that harvesting components out of an existing install base has actually proven out the business case. So that counts as a circular material. There's also a lot of innovation around materials. It's estimated that 60% of the 100 billion tons of materials that enters our economy every year could be grown with biology instead of mined from the planet. So you'll see new bio-based plastics, for example, coming from plants instead of fossil fuels. And then we get to our space, operations. These are the decisions that we own, independent from the business, and could be an example of co-locating operations like we just saw. This is becoming especially popular in water-constrained areas as new factories are going in. Anything that we are using around packaging, water, steam, air, these decisions are ours to own. Now, I understand that this is a great concept, but it comes with challenges, of course. We are fighting 100 years of the linear economy and trying to turn that ship. So let's go through some of the challenges where these circles overlap. Where business models and materials come together, we get markets. This is the #1 issue I hear when speaking with practitioners like you. This is all well and good, Deborah, they say. However, I really can't find enough secondary materials at the right prices. For components, for some industries, like I mentioned, this is shifting. But generally, this is a big market failure, that we're not able to find the materials that we need in order to shift our operations. Where business models and operations come together, I call this strategy. For many of us, as we sit down to do a 3 to 5 year plan or scenario planning, the idea of circular approaches simply don't get included because we're unaware that these options are available to us. So this is a huge issue. We also tend not to have partner ecosystems necessarily that support the data exchanges that we need, and I'll talk a little bit more about that. Lastly, we end up with supply chain, so where materials and operations come together. But our challenges here, again, is that our operations tend to be fairly siloed, even in our own supply chains today. So the idea of exchanging materials at a large scale across our entire value chain seems unlikely. It seems very challenging. But as these all come together, we get to a circular economy, and this should give you enough of the concepts if you go off again and Google or speak to your teams about these concepts to understand the differences between business models, materials, and operations. Let's look more at the characteristics of a circular supply chain so this can start to become more real. First, in a circular supply chain, we will repair more than we build new. Huge shift from today's economy, of course, as our entire world really is fueled by factories and operations and trade and exchanges and transportation. But if we think about taking an item, doing as little to it as we can and getting it back into the hands of a user, we're able to make more money, which is really the economy part of the circular economy that I also don't think gets discussed very much. If the whole world were to transition to a circular economy, which is not likely, it's a $4.5 trillion opportunity. For Europe alone, it's 1.2 billion euros. But even if we only take 20% shift, that still adds money into our operations and into our economies. So this idea of repairing more then shifts our relationship with the point of sale. Today, the point of sale is the end for supply chain. We get an item to where it needs to go, we meet that demand signal, and we get to walk away. In tomorrow's world, in a circular supply chain, the point of sale becomes the beginning of a relationship with our customers. We might offer a service package, we might offer repair services so that we can continue to capture that customer, but they can continue to use our items. And now repair is becoming more popular. I don't know if anybody's seen this show out of the UK, a charming show where they repair old items. But it's starting to uptick. This idea of buying used clothing, for example, is becoming more popular with younger generations. The second, supply chains in a circular economy are shorter. And again, this is a controversial topic in a room full of logisticians. But if we imagine moving production closer to the point of use, or moving repair closer to the point of use. Often, even today, repairing consumer electronics or industrial items, we sometimes ship them all to a centralized location to complete that repair. This is a picture of Cape Town. I'm actually headed there next week for a conference again, and they are looking at this idea of industrial symbiosis, just like they have in Denmark. Innovations in this space, how is it that we're going to move our factories? Unilever sat and thought about this. They've actually put an entire food production line inside of a 40-foot shipping container. This allows them to take it, plop it next to wherever demand they need to meet, produce for a period of time, and move it again. Not to be outdone, Microsoft has done this with servers. And BioNTech, it took them 6 containers, but they managed to put the COVID vaccine production line on wheels, if you will, to move it into resource-constrained environments that weren't being served by the global market. Circular supply chains think about value in different ways. When we think about materials exchanges, how we might define our bill of materials, for example, we can start to take a cue from an innovative company out of Amsterdam called the Excess Materials Exchange. They have the idea that we can describe our products and materials by their characteristics instead of by their chemical properties. And this way we understand the purpose of that product or that material. How hard does it need to be? Does it need to conduct energy, for example? And then they apply machine learning. Before Gen AI was cool, they were doing this to figure out different matches that perhaps we didn't see before. So they're able to use coffee grounds to produce ink, for example. They are successful. They are making money. It's a very interesting company to look up. We also get into some of the circular materials and innovations I mentioned earlier. This is a styrofoam compete. It's actually grown from mushroom spores. How it works is they take agriculture runoff, like corn husks, they press it into a mold, they put in mushroom spores, and a week later, this material has grown. What's lovely is that you're using waste, so your inputs could theoretically be free if you find a partner in agriculture, and then it decomposes in a month versus styrofoam, which decomposes never, essentially. It's called mycelium. It's my favorite material alternative. They're making vegan bacon, leather, all kinds of materials out of this. The biggest mindset shift for me when I learned about the circular economy is that inventory turns are no longer king. Inventory turns, of course, is the mark of a consumption-based linear economy. How much do we push through a system? How fast? Instead, we shift to imagine utilization being the mark of success. If an item is at rest, it's not adding value. So how do we drive up the utilization of the items throughout our supply chains? One example comes from my past. When I worked at GE, it was still one company then, and they realized that airlines don't want to buy and maintain engines. What they want is time in the air. They want to be flying their customers or their cargo around. And this is important because assets, of course, are smart. So we put lots of sensors on an engine, and we measured everything from vibrations to performance, altitude, smog, and then importantly, we compared it to all other airplane engines in the world in order to optimize the use of that engine. How do we keep that item in use? So my company at the time then does this service on behalf of, let's say, Delta Airlines, and Delta only pays for the time that the engine is on the wing. We're responsible for everything else. Those service contracts are the ongoing long-term relationship with the customer. The last characteristic we'll cover today is that our supply chains in a circular economy have to be very, very connected. If we start to imagine that every supply chain is the source of raw materials for another supply chain, we certainly have our suppliers, we certainly have our customers, but now our customers become our suppliers, and our suppliers become our customers, and our competitors might start to become trading partners as well, then we need to know a lot about our supply chains, the materials running through them, and have a fair way to exchange that information. Now, this can be a difficult one to wrap our heads around because we don't really like sharing data. We worry that someone can back into our IP, but there are a lot of discussions about how to do this safely to protect our own operations, our IP, but also to be able to give the materials in our value chains more than one chance to add value. Right, so all of this is a good idea, but how do we put any of this in practice? How can we take this back to our teams, ask a few questions to perhaps get some wheels turning and new ideas going? I don't see circularity as the goal. I see circularity as one strategy for us to use to achieve the goals we already have, which inevitably will be around service level and cost. So how do we think about this? I'll give you 5 questions to ask your team when you go back, if any of this is interesting for you. The first one is, what are the materials that we use the most of, and where do they come from? Just try one material for now. It's very, very difficult to figure out where our materials come from all the way back to the planet. Only 2% of supply chains can see past their tier 2 suppliers. But if we think about a simple supply chain like a t-shirt, that's 5 or 6 tiers, and a complicated supply chain like a car is 20 tiers back to the planet. So if only 2% of supply chains can see past their second tier, this becomes a real challenge for us to do. But if you can accomplish this, you will learn wonderful nuggets about your supply chain. How far does our most popular product travel? Now this one, pick a simple product if you have a simple product in your supply chain. If you're a logistics provider, of course, you can look at the components, the inputs into your service that you offer. This will be remarkably difficult to do if you have a summer intern starting soon. This is a wonderful internship project for them to try to take apart the components, map them back to the planet, and add that all up. So for example, how we heard that a pair of jeans goes 40,000 miles. What's the answer for one of your products? What byproduct or waste do we produce the most of and where? And of course, this helps us to then seek an engagement with the circular materials marketplace. We have all engaged in zero waste operations. I think zero waste to landfill has become quite common, but we will always produce waste. So wherever that output is, there's a very interesting device, which I have high hopes for, that you can put on the back of a truck at the tailpipe, and it absorbs, it captures 85% of the carbon coming out of the tailpipe. Very cool. You can sell it. You can actually make money off of it. The problem is it's very heavy. So logistics providers don't love this because it weighs out our loads before we cube out. So once they figure that out, I don't know how we'll solve for that, but it's a really cool device. It's a company called Remora. Where are we most vulnerable? This one I think you probably already have a really good idea about, thanks to these last couple of years and today's operating environment. But our vulnerabilities point us to where a different approach is needed to be successful. And the last question you can ask, what are our emissions levels for the last 5 years? Have you started engaging in measuring emissions, trying to measure emissions, thinking about emissions? We have one. It's coming. It's coming. The European Union has started something called CBAM, which is measuring high carbon materials as they cross a border into the EU. I predict a tariff will follow in the next 5 years. This will inspire 2 actions. 1, it will change the way that our materials are produced wherever they are produced in the world. Or 2, it will create a materials marketplace inside the EU. So if an item never crosses the border, it will never be subject to that tax. All right, 3 principles. Remember these as you go home. First, eliminate the idea of waste. And we can do this by moving operations closer to the point of use if possible. More likely, we'll complete in-market repairs and produce these services closer to the item to reduce transit time. The good news is this should also save us money. Then we want to circulate our items. We're going to do this by starting with a finished good first, repairing it, and putting it back into use. One thing we didn't talk about today, but I heard mentioned at the beginning of the opening, is about employment. It may sound counterintuitive if we increase the people hours needed to produce repairs, but we dramatically reduce the amount of materials we need. It actually costs less to create work in a circular economy. So we can employ more people while still having that decoupling effect to increase revenue while reducing our reliance on the planet. Last, we can regenerate the environment. Now, this is the hardest one to get our heads around. How do we possibly make money while also somehow leaving this place better than how we found it? So the example I'll give is also a controversial topic, the idea of taking carbon out of the air. Now, this is a very expensive, fairly inefficient process today. But if we start imagining capturing carbon at point of emission, then it becomes a lot more efficient. And this is launching. Of course, we can use carbon for lots of different, as an input to our supply chains. Zara is making party dresses. There's, in the top middle there, protein being made. It's not really plant-based, it's like air-based. They call it air meat. This is actually a NASA idea from the 1970s. How do we feed our astronauts as they are out in space? Well, that's easy. We'll just capture the CO2 that they breathe, and we turn that into a protein. A scientist found this recently. She has created a company around this. It's working out of CO2. They're making vodka. They're making building materials. So we can make items out of carbon. This material that we've declared an issue. But again, carbon's not the problem. It's just that it's escaped our value chain. So if we find a way to recapture or prevent that escape from happening in the first place, then we can use carbon as a relatively free-ish input into our processes. This again gets to the idea of innovative materials, and there's our Venn diagram of the circular economy. One call out I'll give because I find it very amusing. This is a company who has said that they pull out 20 metric tons of CO2 per carat of diamond that they make. I'm not sure how the math works out on that and have not been able to verify it. But if we think about what 1 ton of CO2 translates into, we actually have a pretty decent offset for 20 tons per carat on our diamonds there. 3 principles of the circular economy. Please remember to take them in order. That first principle should be taken first to eliminate the idea of waste and decouple our growth from the materials that we use. If this is interesting to you, my nonprofit worked together last year with the Ellen MacArthur Foundation to produce a white paper and a fact sheet on circular supply chains. This QR code takes you to 2 papers, a longer one and a very short one that summarizes what is a circular supply chain, what can it offer your operations, and of course, some of the very real challenges that we'll encounter as we start to talk to our organizations and partners about this concept. The last message I'll leave you with is your power as a supply chain and logistics professional far outweighs your power as a consumer. The decisions you make every day make a huge difference around the world, around the communities that we all work in. It may seem untrue or you're unconnected to that decision, the impact of the decision that you make, but every time we enter a number into a computer screen or move an item, make an item, source an item, there's global implications as we've seen as our items move all around the world. If you have any confusion about the impact you make in the world, please find me at a break, and I'd love to share my thoughts with you. Thank you very much.
Great, thank you. Thank you very much. Great presentation. And you really, 84 slides it was, right? Very efficient. You can tell logistics is your sector. So we do have some questions already up there, and I see, oh, great. I don't need to translate you any of them. They all made it up there in English. Fantastic. We got 3 questions so far, so if you've got questions, you can ask. Můžete položit dotazy, klidně I v češtině přeložím. So, first question here. You're from the United States. We're in Europe, so we need to look at that. How does Europe compare to the US in circularity? What do you see here? How do you see over there? And what about other parts of the world?
Absolutely. Look, Europe is ahead. There has been a circular economy task force coming out of the European New Green Deal. That has led to the establishments of new circular economy standards, which are badly needed, and those are owned by ISO. So now you can get your process ISO certified to be circular, and they've just released those a few weeks ago. There are a lot of free open resources coming out of that work, and then most of the innovators are here in Europe. So Ellen MacArthur Foundation is based in the UK. There's another organization that's worth looking up called Circle Economy. They do a fantastic annual report and a look at the world. Today, we've actually slid back in how circular the world is. A few years ago, the first time they published this report, we were about 9.5% circular as a world. Now we're more like 7.2% circular. But the goal is not 100%. I'll just mention that, depending on what it is we're trying to do. We are not having endless resources, so we do need to think about that. But if we think about circularity as a lever for climate change, for example, the goal is really 20%. Double, triple where we are today. That means 1 in 5 items should be repaired instead of built new. To me, that doesn't seem impossible. And if we do that 1 in 5 or a 20%, that will close the climate gap that we have globally. So it's a pretty powerful tool for our own supply chains, but also for the entire world. And again, that organization is Circle Economy out of Europe. Other countries are there. I'd say Brazil is actually a leader in this space. They have deeply engaged with the Ellen MacArthur Foundation. They have quite a few innovators, both on the technology side and the process side. Some of those cities can be seen on the Ellen MacArthur Foundation website, who have self-selected into showcasing the work that their municipalities are doing.
Okay, good. Now let's look at the world. Good question here. Does it make sense to be circular here in Europe if countries like China and India certainly are not? And won't we only lose our market position?
Interesting that you say certainly are not. Just this week I saw
okay.
a very, very interesting article on China. An economist has done a study on their battery recycling program. And they say within a few years, China will not need to mine lithium at all because of the scale of their reuse, their ability to process EV batteries, for example. You may be familiar that China's uptick of EV has been impressive and dramatic, but now they have this issue of the grid, of charging, and what happens as the batteries run out. And they seem to have solved that problem. And India is an interesting one. There are many informal waste pickers. That's an entire community of people who do find, transform, and resell items informally today. India is a very interesting one, though, just given the pure density of population. What's interesting is that I would not mentally group circular economy together with sustainability. I think you can achieve both goals, but circular economy should be an economic model, a strategy to grow your business while reducing the risks and reliances we have had on natural resources. So if we think about this question and framed, will we lose out? I think it's quite the opposite. I think by establishing these rules that the EU has done, we'll actually see a huge competitive advantage for Europe over other countries.
Okay, good. Now we're at a logistics congress, so we've got a lot of logistics managers here. One of the questions here, how can logistics managers influence their production departments to be circular, and what first steps can the logistics departments themselves take?
Absolutely. One interesting group to follow is the MIT Center for Logistics. They've done quite a few studies on that might challenge some of our thinking. For example, when they look at the best way to plan a route. Today, of course, we take into account cost and service level. If we add carbon on top of that, for example, it might make sense to drive further distance, but drop off our heaviest loads first, and we end up emitting less because the truck works less hard, for example. Opening the dialogue around changing our logistics provisions, our services that we offer, can be one way to be a good thought partner together with your teams, with your partners. I think logistics in general will see a shift. I do think we're going to have more regional supply chains, but ocean, for example, is one of the most efficient ways to move anything around the world, so I don't see a huge shift soon. But I do think we'll end up seeing more of this production in country, although I suspect it'll take more like 10 or 15 years.
Okay, great. Again, connected supply chain's great, but what about today's geopolitics, where powers are competing and silently fighting for resources?
This is an interesting one. So if I think about even in the US, the amount of money coming from my government for what we call the CHIPS Act to bring semiconductor production into the United States, the catalyst for that is geopolitical. But it's interesting because now we get support from, I would say, two ends of the political spectrum. One that wants production to return to America for a nationalist perspective, and the other that wants shorter supply chains from an environmental perspective, and both win. So as we see this regionalization or insourcing protection of our global supply chains for geopolitical reasons, I think there can be a double-double, a benefit to that as we plan this. The shift in nearshoring or friendshoring is a unique one right now, and the ability to have access to renewable energy, to more networks that can help us serve local communities, it's a unique time to include those decision factors as we rethink our networks.
Yeah, nearshoring, a big topic, and we've actually got a really interesting case study this afternoon on nearshoring as well. So there's one more question that disappeared. Maybe they deleted the wrong one, but it was on who should be pushing for the circular supply chain? Consumers, producers, or regulators?
I am not of the opinion that we wait for consumers. There's a huge perspective that consumers care, so we need to do it. Ultimately, it'll drive business. We actually see the research shows a say-do gap. Consumers say they care, but when they have to go and spend more money on a green product, they don't. However, if we think back to 1924 and the light bulb, consumers didn't ask for their light bulbs to last half as long. We don't ask for our products to stop working. It was not that long ago that our washers and dryers were shipped to us with manuals and a bag of spare parts for how to fix your own washing machine. But of course, we don't do that now, and we didn't ask for that as consumers. So I'm of the mindset that consumers didn't get us into this perspective, and I don't see why we should wait for them to demand for us to get out of it. I actually think we're going to end up switching the way that we run our supply chains, and the consumers will never know. Sometimes I liken this to a Tom Cruise movie with Mission Impossible, and we'll figure out how to avoid impending doom because of our decisions. So I'm definitely of the mindset that industry should do it because the benefits it brings to our operations, but ultimately regulators will prompt this and will push this along. And again, we're starting to see that transition, the shift with regulations such as CBAM.
Okay, great. I think those are the last two questions. So unless there are any others quickly that can come? I guess not. Then I'll thank you very much for a fantastic presentation and a good question and answer after. So thank you very much for your presentation. Thank everybody for listening. And one more round of applause for Deborah Dull.
Thank you.
Great.